Hey everyone! In this video, I want to talk about how to find the derivative of an inverse function. Now this is a neat little process that actually allows us to find the derivative of an inverse function without actually having to know what the inverse function is. So to start off with, let's remind ourselves of what inverse functions are. So let's say we have two functions, we'll call them f of x and g of x. And let's say that these are inverses to each other. Now what that means is that these two functions, they basically undo each other. So for example, if I take g of f of x, the function g undoes the function f, and all I'm left with is just x. Now this definition for an inverse, this is actually what we want to start with as we derive a formula, a rule for the derivative of inverses. So from here, we're going to take the derivative of both sides. So the derivative with respect to x, and on the left-hand side here, we do have a composite function, so we're going to need to use the chain rule. And then the right-hand side, we'll take the derivative of just x. So on the left-hand side, using the chain rule, we have the derivative of the outside, so g prime of f of x. And then we need to multiply this by the derivative of the inside, which is going to be f prime of x. And on the right-hand side, the derivative of x is equal to 1. Now the next thing is we're going to divide both sides by f prime of x. And after doing this, we actually end up with the formula, the rule that we want to use to find the derivative of an inverse. So we end up with g prime of f of x is equal to 1 over f prime of x. So in other words, the derivative of a function is equal to the reciprocal of the derivative of its inverse. The only thing that we need to be careful of here are the values that are in these two derivatives. So in the derivative of g, we have f of x. In the derivative of f, it's just x. So it's important to remember what this notation means. So for example, in function f, if I plug in the value for x, my y value is expressed as f of x. So inside my function f is going to go my x value, and inside the function g is the y value that's associated with that. So to help explain that a little bit more, let's take a look at an example. Okay, so this example says, let f and g be functions that are differentiable everywhere if g is the inverse of f, and if g of 1 is equal to 3, f prime of 3 is equal to -5, we want to find the value of g prime of 1. Okay, so the first thing, if g of 1 is equal to 3, that means the point 1, 3 is on the graph of our function g. That also means that, so if f is the inverse of g, that means that the function value of 3 is going to be equal to 1, because the x and the y values, they switch with inverses. So this means that the point 3, 1 is going to be on the graph of the function f. We're also given that f prime of 3 is equal to -5. So the formula we just came up with, so g prime of f of x is equal to 1 over f prime of x. Okay, taking a look at what's inside these two functions, remember f of x is the y value that's associated with this x value inside our function f. So if I want to find g prime of 1, okay, this is the y value, we're going to take a look at the reciprocal of f prime. So our point here, if the y value is 1, that goes with this x value of 3. So the reciprocal of f prime of 3. They told us what f prime of 3 is equal to, so the derivative of g at 1 is going to be equal to -1/5. Okay, let's try one more We'll just go through that process one more time to make sense of this. So the second example says the function f of x is equal to x to the fifth plus x, and it has an inverse function g. And we want to find g prime of 2. So we want to find the derivative of g at 2. So let's just think about our formula again. So the derivative of g at f of x is equal to 1 over f prime of x. So we want to find g prime of 2. So 2, that's the value of f of x. So what we need to do first is we actually need to find the x value that would go into the function f that's going to give me this y value of 2. So we want to find what value of x, if I plug it into this function, is going to give me 2. Just taking a look at this, I can see that there's one option here. If x is 1, I will get 2. So our solution here is x is 1. And what that means is the point 1, 2 is on the graph of the function f. So in other words, if I want to find g prime of 2, what I need to evaluate is 1 over the derivative of f at 1. Inside the function f is the x value, inside the function g is my y value. So we need a couple things here. First, I need to find the derivative of f, and then I need to evaluate it at 1. So let's find f prime of x first. So just using the power rule, the derivative of x to the fifth is 5x to the fourth, and the derivative of x is 1. And then to find f prime of 1, we'll just plug in 1 for x. So 5 times 1 to the fourth plus 1. We end up with f prime of 1 is equal to 6. And now we can plug that in to our formula over here. So the derivative of g at 2 is equal to 1 over f prime of 1, which we just found to be 6. So again, the derivative of a function is equal to the reciprocal of its inverse. The only thing that we need to be careful of is making sure that we're using the correct function values for these two derivatives.